Hello everyone. In this video, I'll talk about what Jensens inequality is, how you should think about it, and one example problem using it. So first off, a function is called convex if its second derivative is at least 0 for all x in its domain. If the reverse inequality holds, the function is called concave. So what Jensens inequality says is that Jensens, it looks like Jensens, but pretty sure it's pronounced Jensens. So if you have a convex function, the average of the outputs is going to be at least the output of the average of some of n real numbers, a1 to an. So it might be a little bit hard to understand why this is true and how to remember it. So in general, I don't bother remembering what it says. I just remember a picture like this. So here we have this function f of x is x squared. You can check its second derivative is greater than 0. And I just picked 4 points on it. So the 4 points were negative 1, 1, 0, 0, 1, 1, and 2, 4. So what the left-hand side says is we add up the y coordinates of these 4 points and we take their average. So I put a point like that right there. So let's see, the y coordinates is 1 plus 0 plus 1 plus 4 over 4, which is, so the red point has y coordinate 3/2. The right-hand side says if you plug in the average of the x coordinates into the function, it's going to be, well, less than the left-hand side. So the x coordinates were these numbers. Their average is 1/2. So f of 1/2 is just this blue point right here. So if you see, the left-hand side is actually just the centroid of all the 4 points of the polygon formed by connecting the 4 points on the curve. So I'll just call this the centroid because of A, B, C, D. This is the centroid because I put its x coordinate at the average of all the x coordinates, and its y coordinate is the average of all the y coordinates. So this is at the point Q is at 1/2, 3/2. And then you can clearly see that because f is convex, this polygon lies strictly above the curve or above the function itself. So its centroid should be above the point on its curve that, is f of the average of all of the points, which is P here. So, a picture like this should come to mind when you think about Jensens inequality, so you don't have to remember some random algebraic statement like this. This is the intuition behind it. It's not a rigorous proof, but this is what you should think of. So now let's just solve a problem using Jensens inequality. So this is from 103 trig problems. It says let ABC be a triangle. So A, B, and C have all angles less than 180 degrees. Prove that sine A plus sine B plus sine C is less than that, 3√3/2. A plus B, I'll just use degrees. You can use radians too. So if we look at a sine curve, well, technically the whole function is not, we're going to use Jensens inequality. So technically a sine curve is not completely convex or concave. But since we're only worried about the interval from 0 to 180 degrees, we can check that from 0 to pi radians, sine is actually concave. So sine x, let's say the function is sine x. And then f prime x would be cosine x. F double prime x would be negative sine x. And this is always less than or equal to 0 because its graph looks like this. If x is for all x in the interval from, I'll just write from 0 to pi. Okay, so that means we can use Jensens inequality, but the inequality is reversed. So if we take any 3 points here, let's say, and we draw, a polygon, we can see, oh, the inequality should say the centroid of this polygon is above the curve. Oh, sorry. The original function sine x, the centroid of its polygon is below the curve. I'm not sure why I'm looking at its second derivative graph, but yeah, so let's just erase that. It's not relevant. So let's see. Jensens inequality says that I'll just write f equals sine x. So instead of sine x, we'll say f of a plus f of b. And these are just some angle measures, 3 angles that add up to 180 degrees. So this is going to be less than or equal to, because the function is concave in the interval from 0 to pi. So concave from there to there is less than f of, well, now you take f of the average of the 3 points. And since this is a triangle, this is just f of 60 degrees, because a plus b plus c is 180 degrees. So sine of 60 degrees is root 3 over 2. And the left-hand side just says sine of a plus sine of b plus sine of c all over 3 is less than or equal to this term. Let's just rewrite it here. And yeah, so that if we multiply by 3, we get exactly the inequality above. Can move the 3 over, and we've proven the inequality. So notice here, we didn't need to check concavity or convexity for the whole function. We just needed to check that it was concave in the interval that we cared about. And Jensens applies, for intervals as well as the whole domain of the function. So yeah, that'll be it for this video. If you have any questions or comments, you can leave it into the comments below.